Well, firstly, John Wolfe Barry was the principal collaborator with Sir Horace Jones from the City of London Corporation. He was an architect by profession, therefore he could take his concepts and ideas so far, and he was very influential on what we see behind us. And John Wolfe Barry was a consulting engineer, very eminent at the time, at the peak of his powers, and he was asked by Horace Jones to effectively collaborate to make what he wanted to see happen. The Bascule Bridge lifting and in a stable position, and shipping still being able to pass through the main channel. He had a lot of help though. He was a partner with Henry Mark Brunel of the Brunel dynasty, son of Isambard. And he seems to me to be the brains behind the big ideas of John Wolfe Barry, and the calculations and the stress analysis, the detailed work, I suspect was mainly Henry Mark Brunel. George Edward Wilson Crutwell, to give him his full title, he was the resident engineer for the duration, 1886 to 1894. He was on site, he knew everything there was needing to be done in the detail of supervising contractors, approving the quality of materials that the contractors wanted to use, signing off how much the contractor should be paid. He was the most influential person on site 100% of the time. Both Barry and Mark Brunel would be back in their offices doing what they did, but Edward Crutwell was here.
There was a whole host of specialisms in engineering and so on. We also have the side which relates to the steelworks, William Arrol, and the design of the mechanics, William Armstrong, etc., etc. Yeah.
Very much so. This is a complex bridge. Most bridges that engineers get an opportunity to design, I used to design bridges, are straightforward. They're carrying either a road or a railway from one side of an obstacle to another. This has got many more dimensions because of the machinery required to lift the bascules and the complexity of the steel and masonry combination and being over a river, and the foundations being super critical in order to make the thing robust and stable and last for a long time as it has. Well, William Arrol was the ultimate steel fabricator specialist. He built a business on being able to produce large amounts of steel fabricated in a way that was put together very efficiently.
William Armstrong was another very important man, wasn't he, with the mechanics and again, groundbreaking design of the accumulators.
Yes. The Armstrong Mitchell Company, as it was then, up in Elswick, Newcastle, was mainly known for breakthroughs in armaments and industrial shipbuilding. It's nice to see them deployed on something peaceful and enduring, as they did with the hydraulic system for the Tower Bridge. And that's a piece of brilliant energy conservation because they recognised that the bascules only had to work intermittently, and a lot of energy was required, but only in intermittent bursts, not continuous. They devised a way to bridge that gap by having continuous steam engines just running away, building up water pressure. But when the bridge wasn't being lifted, that build-up of pressure in the system was fed to the accumulators, as they called them, basically a huge piston in a large tube, heavily weighted. And as the pressure built up, it rose slowly. But all the time it was rising, it was creating more and more potential energy. So when the bridge needed that energy again, it simply turned a lever and that came back into play, and the pressure reduced and it was expended on lifting the bascules instead of raising the piston. Brilliant piece of very efficient engineering. It's the sort of thing that we need today. That's why engineers should always look into the history of their profession. There's always something to be learned.